All right, Precalculus, away we go with section 5.4 on the logarithms. Oh, my lord, the logarithms. The reason we study them is they are the inverse for an exponential function. And the truth is, if there is one function that applies to life outside of our classroom more than any other function, it's the exponential function. It's the way bacteria grows, it's the way population grows, it's the way finances grow. It's the way mold grows in my refrigerator. Everything that grows at a constant rate is usually measured by an exponential function. And so since we have to use them to study many things outside of the math classroom, it makes sense that we should be able to solve exponential equations. For example, enjoy this. On December 7th, 1978, true story, while I was walking home from first grade, I was run over by a chicken truck. I can explain the details at a later time, but that's all definitely true. There was a lawsuit, and I was awarded $5,000. I'm sure if you hit a kid with a car today, that's $1 million, but in 1978, it's $5,000. If I had kept that money in a savings account, which we had put it in a savings account and left it there until I was 16, for these 42 years since that happened, and if the interest rate was the 5.5% that I remember it being at the time, how much money would I have in that account now? No, instead I took that money and I bought a car with it when I was about your age, and on the way to basketball tryouts as a senior, a girl went through a red light and smashed my car and totaled it. Now I've got nothing left but you guys. Anyway, if I had left that in the bank, what would happen? So we saw this equation the other day where A is the amount after everything happens, P is the principal, that means what did you start with, R is the interest rate as a decimal, N is how many times interest gets compounded a year, and if it's compounded daily, that means N is 365. Okay, and T is the amount of time in years, then it's been 42 years since this happened. Let's go with a fun fact here. My dad actually calls me every year on December 7th to wish me a happy anniversary. Yeah, that's something. Anyway, so the amount in the account would be $5,000, my original principal, the amount of money I started with, times 1 plus R over N. So R is 5.5%, but look what I'm doing here. You write it in as a decimal. You don't write it as a percent. Over N, which is 365. And I raise that to an exponent where these two things are multiplied together. 365 times 42. Put all of that in the calculator. You can actually put it in one entry. If you enter that into your calculator correctly, it'll obey the order of operations. I forgot to bring mine home today, so I had to use Excel to figure this out. So anyways, if I had just left it there for 42 years, I would have $50,363.36. I'm pretty sure I could buy a pretty cool car with $50,363.36. What an idiot. Anyway, how long would it take for that 5,000 to have to turn into 100,000? Because maybe I want to go buy like a boat instead of a car. Well, this is how this would start. I would put the 100,000 that I'm looking for to be the end resulting A here. 100,000 is equal to 5,000, and then it'd be 1 plus 0.055 over 365. But here's the thing. Then up here, it would go 365 times T. And I'm in the middle of an equation where I've got every number but T, the amount of time it would take for this to happen. How long would it take? And so I'm trying to solve this equation for an exponent. Well, the first thing I would do is divide by 5,000. And if you divide 100,000 by 5,000, you get 20. Divide by 5,000. I added this together, and look, I'm going to put a whole bunch of decimals here for you. 0.00150,685 to the 365t. Now here's the problem. You're stuck. You have no idea how to solve that. You can't finish this problem with your normal set of operations because we don't have an inverse for an exponential expression. So let's make one. If y equals a to the x is an exponential function, and we learned earlier that inverses are what happen when you switch x and y, the inverse has to be x equals a to the y. Now that doesn't say logarithm at all. We're going to have to rewrite this, and we'll do that on the next page. Go to the next page.